Okay, so I'm going to go over the problems from your What Did You Learn quiz from week 7. I'm also going to go over through some of the helpful things to do while you're taking your AP exam. So question number 1, which for most of you, these questions will probably not be in the exact same order as your test was, but you can try to figure it out because they are in random order. So it says, suppose the average score on the national exam, I spelled that wrong, is 500 with a standard deviation of 100. If each score is increased by 20 and the result is increased by 10%, what are the new mean and standard deviation? Okay, so the first thing that I notice when I'm looking at my answer choices are that I have 3 answer choices with the same mean and 2 that are different. So here's the 2 that are different. So I have 2 that are 570 and the other 2 are 572 for the mean. Right there, I already know without doing any math that these 2 have to be off the table because the way that they write the AP exam, there's always going to be 2, and then the one that's the most common answer, and including the right one, is the one that has the more answer choices. So I know it's going to be one of these 3 with the 562. So without having to do any math, I know that that's the new mean. Now, what I don't know is the standard deviation. So here's what happens. 1, I know that if I increase by 20, all that's doing is just moving my entire graph. So if we have down here, if we have some graph, it's taking it and moving it plus 20 to the right. But it looks exactly the same. So I've done nothing to my standard deviation. I've just increased everything by 20. Now, the tricky part is when I increase by 10%, when I increase by a percent means that I need to do what? I need to multiply and then add that on. So anytime that you're going to be multiplying, that's when I'm affecting the standard deviation. So if I'm just adding things like I was down in the bottom here, that's not going to do anything to my standard deviation. My space between here, between my tick marks, is still going to be the same. But when I start multiplying things, that's when I care about my standard deviation. Now I've increased things. So all I need to do is now figure out what my standard deviation is. So 100 times 10 is going to give me 10, right? 100 times, 10% is going to give me 10. So remember, if you plug that into your calculator, that's 10 times 0.10. So that gives us 10. Now I just need to add it on. So 100 plus 10 gives us a standard deviation of 110. So my S, or they write it as sigma, so we've got 110. So now I know that my answer is going to be, the mean should be 572. We've been writing the mean as x bar, but this is mu. Remember, same thing, just dealing with the population. So it's 572, and my standard deviation is 110. So my answer should be number 1. Okay, for this graph that we're looking at, it says which of the following statement is a true statement. So first I need to look at this picture. So one, I already know that it's not a histogram because the numbers at the bottom are not actually, even though the bars are touching, technically I'm missing some information. So this is not a histogram. Also, I noticed that now that I'm looking at the years, these spans are completely different. So this is 1 year, this is 2 years, and this one's actually 3 years. So they're not even representing the same thing. So in 1 year, it looks like total sales was 200,000, but then in 2 years, it was 250, so 1,000. So if I take that and divide by 2, that's actually, so this one is 200,000. This one for 1 year is actually 125,000. And if I take the next one, that's actually only 100,000 because 300,000 divided by 3 would give me $100,000 every year. So this picture may be this picture may be misleading, but it's still a histogram. We know that that's not true because it's not a histogram. To make sales projections, a box plot would be more informative for this data. We don't know that that's true or not because we don't really know what all of the data looks like. The average sale has increased during each of the, well, we know that's not true. It is possible that the total sales per year decreased every year between 2005 and 2013. That is possible. So I'm just going to mark it for right now. Each year since 2005, sales have increased. Well, we know that's not true, that it hasn't increased. So there's your answer. All right, so for this question, it says, when a set of data has suspect outliers, which of the following are preferred measures of central tendency and variability? So remember, variability deals with our spread. And remember, we talked a lot about spread, that there are 3 different ways. One is range, which doesn't tell us very much. 2 is interquartile range. And 3 was standard deviation. So first, we know outliers can skew our mean to the left or to the right, which is why when we have a left skewed graph a right skewed graph, or a left skewed graph, it's pulling the mean in the direction of our outliers. So we know that if there are suspect outliers, the mean should not be used. So all of these 3 choices are out already because it's messing with the mean. So now the only thing that I have to decide is an outlier going to affect the range? Yes, because I'm taking the range is max minus min. So I know that my answer should be median and interquartile range because my outliers are not going to affect those. In which of the following histograms is the mean less than the median? The mean less than the median. So I am looking for something that is left skewed. It's pulling my mean to the left. So I look for the tail that's on the left, which is C. And that's your answer. If the standard deviation of a set of observations is 0, you can conclude that a mistake in arithmetic has been made, none of the above, that the average value is 0, that all the observations are the same value, that there is no relationship between the observations. Okay, so let's think about this. If the standard deviation of a set of observations is 0, okay, so what that means is there is no variability or spread. No spread. So if there's no spread, what would that look like on a graph? Well, let's say we have the number 10 down here for my bar. And let's say we just have 20 different numbers, and all of the numbers are 10, for whatever that represents. Do I have a spread here? No, because all of the numbers are 10. So I'm not spreading anywhere. I'm just staying at 10. Is there any variability? No, because they're all the same number. So my standard deviation here is 0, because I don't have anywhere to go. I don't have any other numbers in here. So it would be that all of the observations are the same value.